Here we are on question 3. So question 3 is from 2011 scoring guidelines, question 1. So AP Statistics 2011 scoring guidelines, go to question 1. If you want to read through the scoring guideline in more detail after you watch the video or before, it's just good to see what I wrote too. So part A, based on the relationship between mean standard deviation and minimum time, is it reasonable to believe the distribution of 40-yard running time is approximately normal? Explain. So when I said no, if data is normal, then 95% of data is within 2 standard deviations of the mean, meaning 2.5% of time should be below 2 standard deviations, which would be 4.3 seconds. However, the minimum here is 4.4 seconds. So that was not super detailed. Hopefully it's enough. So for part A, they said, no, it is not reasonable to believe the distribution of 40-yard running time is approximately normal because the minimum time is only 1.33 standard deviations below the mean, and a normal distribution approximately 9.2%. So they were very specific, which you can be too if you do inverse just normal CDF. Percent of the z-scores are below negative 1.33. So you would do negative E99 to negative 1.33 with 0 and 1 as your mean and standard and normal CDF to get the 9.2%. Or use the empirical rule like I did. Therefore, the distribution of 40-yard running times is not approximately normal. Okay, I think I got the same thing, but let's look at the scoring. Essentially correct if the answer is no. And the response provides a reasonable justification based on the relationship between mean standard deviation and minimum value of a data set whose distribution can be approximated by a normal distribution. Well, it does. So a reasonable explanation should describe a characteristic of a normal distribution that is substantially contradictory to the information given in the running time, so that the running time distribution cannot be reasonably approximated by a normal distribution. Plausible comments about the distribution of running time are considered extraneous. Incorrect comments about the distribution of running time can lower the score 1 level, depending on the severity of the comment. Partially correct if the answer is no, but the explanation is weak. I had this specific percentage. I feel like my explanation is strong. If you feel like yours is not strong, you should mark it as partially correct and figure out how to beef it up a little bit and make it stronger, because we'd rather underestimate our scores than overestimate our scores. Part B. So same z-score, 2.4. The z-score indicates the amount of weight the player can lift is 2.4 standard deviations above the mean for all previous players in this position. This player can lift 2.4 standard deviations of weight more than the average player at this position. Good. So it seems the same. Essentially correct. The response calculates the z-score correctly and provides a correct interpretation that includes direction. So I said more than, you couldn't just say 2.4 standard deviations away. You had to indicate if it was above or below. If you had only one of the 2 components, either your calculation was correct or your interpretation was correct, it's partially correct. Your interpretation has to be correct based on whatever z-score you got. So in this case, context is provided in the stem of the problem and is not required for the response to be considered correct. But you should always have context because they take off for that a lot. So context is where I talk about the weight, average player in this position, this player. I'm talking about what's actually happening in the problem. They didn't take off in this case, but that is something they typically take off for. So I would make sure you have it. And don't take off if you don't have it this time, but I would add it in if you don't have some sort of context. So for part C, so what I did and what they did as well was I calculated a z-score for their time to run 40 yards and their amount of weight lifted, like so. I got all the same z-scores. So the z-score indicates that both players are faster than average in the 40-yard running time, and both players are well above average in the amount of weight lifted. So one of the tricky things on this one is the time it takes to run. You actually want a lower time because that means you run faster. So actually -1.2 is better than -0.2. So that is something to keep in mind. I think the first time I did this question, I might have made that mistake. Because typically we think of positive as being better, but in this case, negative is better. So they're both well above average. Player A is better at running time and player B is better at weightlifting. But the z-score also indicates the difference in their weight, 0.2 standard deviations, is quite small compared to the difference in their running standard deviations, a difference of 1 standard deviation. Therefore, player A is the better choice. I said essentially the same thing. The z-scores for weight are very close, 2.4 versus 2.6, so I'd look at time to make my choice. Player A takes a whole standard deviation less time to finish running 40 yards than player B. Therefore, the team should choose player A. So something like theirs or something like mine. Essentially correct if they selected player A. So make sure you explicitly said what player to choose. Numerical adjustments on the scales so that values can be compared for both variables. So that's my z-scores. Justification of the selection in component 1 by using the player's values on both variables with respect to the adjusted scale. So I said this one is close, but that one's far. You could look at a total time too, where you use the positive 1.2 and positive 0.2. And then add up the time together. That would also be an option. It's not necessary to calculate z-scores. For example, the following response is scored as essentially correct. Players A and B are close in weightlifting because the difference of 5 pounds is much less than 1 standard deviation, but much less close in running time because the difference is 0.15 seconds, which is exactly 1 standard deviation. So they're calculating z-scores without calculating z-scores, basically. Or they're just referring to 1 standard deviation. It's much less versus it's equal to 1. So that's kind of going more into like the empirical role of it. Well, it's not normally distributed. It's not the empirical role. If you have 2 of the 3 components, it's partial. Component 3 is not satisfied by the following statement. Player A should be selected since the weights lifted are close and running time is less close because adjusted scales are not mentioned. So taking into account how many standard deviations that is important. You have to get the credit for the third one. The justification in component 3 must reference the adjusted scale for at least one variable and at least be implied for the other variable. So I did it for both, but he could have implied it, I guess, for the other one. So you shouldn't have calculated probabilities because these are not normally distributed. If you made that mistake in part A, they wouldn't penalize you here if you calculated probabilities. But since it's not normally distributed, you shouldn't have done that. So if you did, it would knock you down a score. Conceptual miscalculation of z-scores or probabilities. For example, using the wrong mean, reversing the order of subtraction, or multiplying probabilities result in loss of credit for component 2. But minor arithmetic mistakes are overlooked. So if I were to set this up correctly and then I wrote down -1.1 instead, or something like that, that would have been overlooked. But if I made a more conceptual error, then I would have been penalized. So just like with most of the 3-part questions, so it should be an E. 3 essentially corrects is a 4 out of 4. 2 E's and a P is a 3 out of 4. EEI, EPP or EPI or PPP are all 2 out of 4. EII or PPI is a 1 out of 4. Less than that is a 0 out of 4.